Now, as you can see, keyboard input only allows firing in the cardinal and ordinal directions from where the player is, i.e. the red and black arrows here. With this, players using mice as an input would get an unfair advantage. As you can see where the cursor is here, a mouse player would be able to shoot in a direction and at an angle that keyboard players wouldn't be able to use. In order to level the playing field, what we do in grits is eliminate that advantage by snapping the firing vector to one of the 8 directions that keyboard controls allow. So if you click where the cursor is now, it would go along the right up vector. Each of the shaded regions corresponds to only one firing vector. We started out the unit talking about how important it was to make sure that every player had a fair experience. But an issue is that mouse players with the current code can actually fire in more directions than keyboard players. So what we need to do is take the actual mouse input and snap it to one of the 8 directions that the keyboards actually have access to. In order to do this, we need to do a little bit more trigonometry. Now, in order to snap the arbitrary directional vector that we're getting from mouse input to one of our 8 directional values that a keyboard player can use, we are going to utilize a lookup table. This lookup table is already populated to contain the 8 directional vectors unitized that keyboard players have access to. Now, the magic sauce here is taking this arbitrary directional vector and turning it into a lookup index that we can then query against the lookup table. For us, we have a magical pixie of a function called getQuantizedAngleIndex. Now, I'll spare you most of the math that's inside of this function because really our intent is not to teach you trigonometry. The overview is this. We use the atan2 function to find the angle between the input directional vector and the x positive vector. This gives us an angle between the two in radians. We then use some nice fun little tricky math here to scale that angle value into an integer between 0 and 7. That 0 and 7 value is passed back and used as an index inside of our lookup table. The result gives us a directional vector that matches exactly what keyboard players can use.